Welcome to AI Frontiers. Today's episode explores AI's visual revolution, synthesizing 43 computer vision papers from November 1, 2025. Cutting-edge advancements in how machines see and interpret the world are examined, from anomaly detection to medical diagnostics and 3D reconstruction. Innovations that bridge real-world applications and ethical AI are highlighted. This presentation dives into computer vision's latest breakthroughs. Imagine AI spotting factory defects or diagnosing diseases across continents. This is today's reality. 43 papers are synthesized into key themes, findings, and future paths. A journey from field basics to standout studies is offered, blending insights for an engaging story. The narrative focuses on AI's evolving eyes in healthcare, industry, and beyond. This is perfect for enthusiasts curious about visual AI's transformative power. Computer vision is understood as enabling machines to interpret images, videos, and 3D scenes like humans. It powers self-driving cars, medical diagnostics, and security systems by turning visuals into insights. Driven by deep learning, it handles object recognition, anomaly detection, and scene generation. Challenges include biases, efficiency on limited hardware, and real-world data messiness. These 43 papers showcase its growth in healthcare, manufacturing, and cultural preservation. A key theme is anomaly detection and robustness in visual data, enhancing AI's ability to detect defects in real time, vital for industries. Zhu et al. Introduced the Real-IAD Variety dataset with 198,000 images for scalable testing. Yu et al. Benchmark context-aware video anomalies, improving surveillance accuracy. Methods like temporal recall, as presented by Siddiqui et al., use embeddings for efficient detection. This theme overlaps with efficiency, enabling robust systems in factories and security. Building robustness continues in this theme, overcoming scale and variability. Vision language models boost generalization by 24% on diverse datasets, as shown by Zhu et al. Real-world variety is addressed, from industrial defects to video outliers. The technical concept of contrastive learning creates robust features from unlabeled data, explained as pairing similar images to learn differences. This links to bias mitigation for fair, adaptable AI across domains. Medical imaging and diagnostics form another major theme, focusing on inclusive and explainable AI for health. Equitable diagnostics are emphasized, tackling biases in global healthcare. Massaroli et al. Validate Alzheimer's models across populations, revealing domain shifts. Nguyen et al. Create the VIN-DRC-XRVQA dataset for chest X-ray question answering. Multitask learning with explanations, as in Shahi et al., aids pneumonia detection. Low-dose CT optimization is emphasized, as explored by Yusra et al., for safer scans. The theme of 3D and 4D scene understanding and generation involves reconstructing dynamic worlds. Innovations in rendering and tracking support VR, robotics, and heritage preservation. Wu et al. Developed 4D neural voxel splatting for efficient dynamic scenes. Kondakar Ope et al. Use OITIJJO 3D for heritage reconstruction from street view imagery. Luo et al. Advance omnidirectional multi-object tracking with OmniTrack++. The technical concept of Gaussian splatting renders scenes by modeling points as 3D blobs, enabling fast, high-quality visuals. Key findings across the papers reveal critical insights. In anomaly detection, vision language models improve generalization by 24%, as per Zhu et al. In medical AI, normalization fixes domain shifts, boosting AUC from 0.80 to higher values, according to Massaroli et al. For 4D rendering, 75% memory reduction is achieved with real-time quality, as demonstrated by Wu et al. Fake detection through diffusion methods reaches 99% accuracy under distortions, as in Amin et al. Bias mitigation via test time techniques enhances fairness by 5% without retraining, noted by Wu et al. Methodologies are synthesized, highlighting common approaches. Contrastive learning builds robust features from unlabeled data, strong for generalization but sensitive to noise. Transformers capture long-range dependencies in videos, achieving high AUC but proving memory-intensive. Gaussian splatting enables efficient 3D rendering, reducing overhead versus radiance fields. Vision language models like CLIP allow zero-shot tasks, vulnerable to biases and less debiased. Diffusion models generate or detect fakes via noise processes, offering quality but remaining computationally heavy. The first selected research paper is by Massaroli et al., 2025. Titled Validating Deep Models for Alzheimer's 18-FFDG PET Diagnosis Across Populations. A study with Latin American data. It is selected for its impact on inclusive healthcare, exposing biases and providing fixes for global equity. The objective is to mitigate domain shifts in Alzheimer's diagnostics across populations. Methods involve training models on ADNI, testing on Argentine data with normalization and occlusion analysis. Findings show normalization improves robustness, with significance in equitable AI for underserved regions. The second selected research paper is by Zhu et al., 2025, titled Real-IAD Variety, Pushing Industrial Anomaly Detection Dataset to a Modern Era. It is chosen for novelty in scaling datasets, representing the robustness theme with practical industrial applications. The objective is to create a benchmark for large-scale anomaly detection in manufacturing. Methods include assembling 198,000 images and benchmarking vision language models in zero-shot settings. Findings indicate a 24% generalization boost, setting a new standard for adaptable AI in diverse industries. The third selected research paper is by Wu et al., 2025, titled 4D Neural Voxel Splatting. Dynamic scene rendering with voxelized Gaussian splatting. It is selected for representativeness of 3D and 4D innovation, with high impact on VR and simulations. The objective is to efficiently render dynamic 4D scenes with low memory. Methods use neural voxels with deformation fields, trained on DyNerf for reconstruction. Findings include a 75% memory cut in real-time speeds, bridging to accessible immersive tech. Future directions in computer vision research point to tighter multimodal fusion with language and audio for comprehensive scene understanding. Foundation models will evolve for zero-shot tasks, emphasizing diverse, ethical datasets. Efficiency will focus on edge computing for mobile and drone applications. Advanced deepfakes must be combated, and privacy ensured in federated systems. Physics-informed hybrids and neuroscience-inspired models will be explored for robustness. This deck was synthesized using AI tools. GPT-Grok with model Grok 40709 for content generation. TTS synthesis was performed via OpenAI for audio narration. Image generation was handled using Google for visual elements. A review by a human expert ensured accuracy. Note that some oversights may exist. All references are provided for verification. Subscribe to the YouTube channel for more deep dives into AI research. The channel title is AI Frontiers. Stay updated on cutting-edge papers and narratives. Hit that subscribe button. Share thoughts and suggest topics for future episodes. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprintserver.org.